So pain is obviously incredibly important for us. It helps actually keep us out of danger, alerts us to problems in the environment. So it's caused by tissue injury or anything noxious in the body, and we are going to take measures in order to deal with the pain and remove it from our body. There are two types of pain receptors. We have those that provide fast travel for pain. This is the sharp, stabbing kind of pain. It travels very quickly, as you see, typically on type B fibers, maybe even type A's occasionally. And then there's the slow pain that travels in type C fibers. And this is your dull, aching, chronic pain that won't go away. Now, that's a totally different situation. There's pain that derives from the body wall, from muscles, from joints, and so forth. And then there's the pain associated with your organs, your viscera. And so sometimes this can be hard to localize. We'll talk about this in a second, because the brain is really designed to deal with bodily pain, with that pain coming from your joints, from your muscles, from your body wall. So there's always a preference there. Now, when tissues are damaged, which is what pain is, they'll start secreting chemicals. And the most potent chemical that leads to pain development is bradykinin. So you need to know this particular chemical that leads to activation of first order neurons out in the body wall. So there are two pathways that we're going to see pain takes, and of course those pathways can diverge into many other routes. There are pain signals from the head, and these are going to involve the nerve cell bodies of these four cranial nerves, and you should be able to name these right off the top of your head. Cranial nerve 5, trigeminal, 7, facial, 9, glossopharyngeal, and 10, vagus, right? You should be able to do that. Those are the ones that are going to transmit the pain information from the head. And then we're going to see the second order neurons decussate, so the pain crosses over to the opposite side of the body, sends it up through the spinal thalamic tract to the medulla, through the medulla to the thalamus, and then delivers it to that part of the postcentral gyrus that would correspond to that position on the head. Now, for other aspects, when we talk about pain from the body, from the neck down, we're talking about three ascending tracts. And we've already discussed these, right? The spinothalamic, spinal reticular, and the posterior column. Remember, when you see this one, you're thinking, aha, this is going to give us some type of relief from our pain. And that's quite possible. So the spinothalamic tract is absolutely number one tract for delivering pain information from the body. The spinal reticular has the capability to ameliorate or reduce the amount of pain that's being sensed. And then the posterior column is going to deliver some visceral pain from the body. Okay, so here are our pathways from pain. We stab our finger, it goes forth. Here's the separation into two different pathways, one heading up through the reticular formation, the other heading to the thalamus and delivered to that part of the brain tissue in the cerebrum that's going to deal with it. So this leads to the notion of referred pain. So this is the battle in the body of visceral pain versus somatic pain. And again, every time the brain's going to err on the side of somatic pain over visceral pain. How do we know? Well, think of a heart attack. Why is it, and this is more true for men than women, why is it that men will generally feel pain from a heart attack along the inner surface of their arm? Well, the fibers that are delivering the pain information from the heart are going to collect with the fibers that are delivering the information from the arm, and they're going to join up and enter basically through the same pathways. The brain's going to get that, and it's going to have a hard time telling where the information is coming from, and it's going to get confused, and it's going to say there's no way that this pain can be coming from the heart. It has to be delivered from the inner surface of my arm, so in response it will cause a pain sensation to be felt from this area, not from your heart, which is where it's really at. And this is called referred pain. Okay, so this convergence we've talking about is that the heart pathway, pain pathways converging with the inner arm pain pathways. So the brain always assumes visceral pain is coming from the skin if there is a conflict at all. Okay, and this is what we were just discussing with the heart and its referred pain. And so this shows you that if you are an asthmatic, you will typically feel pain. You might get a early pain sensation from your neck and upper chest region, even though it's down here where the asthma is occurring at. The heart, this is what we were talking about with men, feeling heart pain along the inner portion of your arm. You can see some of the other areas of referred pain that occur. Kidneys can be quite widespread with kidney pain, pretty much anywhere there's yellow at. So referred pain is an oddity, but it refers to the way that the brain processes pain and prefers to consider pain from the somatic areas of the body rather than the visceral areas of the body. So recall, we have analgesic effects by the reticular formation. It's just now beginning to get understood. We're not going to talk a whole lot about it, but it has to do with operation of receptors for opium and morphine and heroin inside the body. And these types of receptors called opioid and encephaloid receptors are the ones responsible for this reduction of pain. Okay, so the normal pain pathway, the nociceptors then will be stimulated by the bradykinin that's released from the cells that have been damaged. That will stimulate the primary, the first order neuron, delivers the information to the second order neuron. The neurotransmitter released here is called substance P, P for pain, right? That's going to activate the third order neuron. The first order neuron is going to release substance P at the synapse. Then the second order neuron is activated. It's going to deliver the information to the thalamus, where a synapse then delivers the information to the third order neuron and up to the postcentral gyrus, where it is dealt with in the